In this video, I want to use this function to answer 12 questions. The instructions find each of the following or explain why they do not exist. So to start off, the first 6 are just about some function values. The next 7 questions I have written over here, and I'll bring them back after we do the first 6, and they ask me limit questions. The function value questions are asking, hey, when I plug in -5 to this function, what do I get out? The limit question is saying, hey, when x gets really close to -5, what happens to the y values? So let's start with the function values and just think what happens. Throughout this whole problem, I'm going to write my answer separately from the problem. I know I could just write equals or does not exist, but I actually want to have space to rewrite it, and I also want to make a point of using correct notation through the whole problem. F of -5. All right, so let's see. 1, 2, 3, 4, -5. There is no function value there. F of -5, so this is problem number 1, does not exist. And the reason for that is because -5 is not in the domain. Two. F of -3. 1, 2, -3. Hey, there is a function value there. F of -3 is 1. Problem 3. F of -2. 1, 2, no function value there. That does not exist. And again, I can simply say, because -2 is not in the domain, F of -1, that's 2. Plug in a -2, get out that point filled in there at positive. Excuse me, F of -1. Get out a +2. Easy for me to say. F of 0 does not exist. I can say 0 is not in the domain. I could also say there's a Vertical asymptote there. And then 6, F of 3. Well, x equals 3, 1, 2, 3. I get out that function value there. 1, 2, 3. 1, 2, 3. F of 3 is 3. All right, so those are those nice, happy function values. Now I'm asked to answer these 6 questions about limits. And I want to keep track of my answers in the same kind of way, using correct notation the whole way through. I have my function values written here. I think I will just put the answers here without rewriting them, try to get an explanation fit in the same spot, but I want to make a point about the notation as I do. So maybe number 7. Well, 7 we can just answer, and then maybe I'll pick one of them to rewrite up here separately so I can talk about how to use the correct notation. All right, so the limit as x approaches -5 of f of x. 1, 2, 3, 4, -5. All right, well, if x got close to -5 on this side, it looks like my y values are always 1, but on this side, none of the y values are defined. So I'm not getting closer to a single number as I approach -5. So I have to tell you this one does not exist. There are no y values on the left-hand side. Sorry, I have a little bit less room there than I would like, but we're going to make it work. X approaches -3, -1, -2, -3, and here I have that idea from that step function in the last video. That from the left-hand side, it looks like my y values are 1, and on the right-hand side, it looks like they're all getting closer and closer to being 2. So this limit does not exist, and I'm just going to say for right now, it looks like there's a step there. We'll have a more precise way of writing down that reason later on. The limit as x approaches -2. All right, well, there's -2. Well, as I approach x equals -2 from this side and this side, it looks like I'm going to the same value at 1, 2, 3. This is one I think I'll take over here and write my answer as if I was doing the problem without just penciling it in here. And the point I want to make is I have to write everything down. The limit as x approaches minus 2 of this function f of x is equal to 3. So all my y values are getting closer and closer to 3 when x gets closer and closer to minus 2 without actually being minus 2. Students have this tendency to leave out the function there and write limit as x approaches minus 2 equal 3. Do not do this, ever. This statement has no meaning. Without a function in there, this is meaningless. This is supposed to say the limit as x approaches minus 2 of f of x is equal to 3. Every time you write down a limit statement, you have to write a function in there. Whether it be written out as an expression or just a placeholder, its name f of x, you have to include it. If you don't use correct notation when you're writing out your lab problems or test problems, I will take off points. So never leave out the function when you're writing down a limit. All right, the limit as x approaches minus 1. Hey, my y values on both sides are getting closer and closer to 2. X gets close to minus 1, the y values get closer to 2. And again, in this problem, the function value at minus 1 is actually 2, and in this problem, the function value at minus 2 does not exist, and that's okay. The limits are only talking about what happens when I get close to an x value. It doesn't actually matter what happens there. The limit as x approaches 0, I grow without bound on both sides. This limit does not exist. The y's are growing without bound. And then finally, the limit as x approaches 3. Well, 1, 2, 3. From both sides, my y values are getting closer and closer to being 1. It doesn't matter that the function value is defined to be up there because I don't care what happens at 3. I only care what happens when I get really, really close to 3. All right, well, there are 12 little problems about this function. 6 limits, 6 function values. The limit is describing what happens to the y values when x gets close to something. The function values are supposed to describe what happens actually at that point. The limit is not necessarily the same as a function value. All right, well, that's it for now. I'll be back with more later on.